This is a pre-calculus Onramps question about side lengths and trigonometric ratios, finding side lengths. There's really two ways to do this. I guess at this point in this particular pre-calculus Onramps, and it's December 1, they don't have law of sines yet. So law of sines is this. I'll show how to do this with law of sine first. That's supposed to be a triangle. And these angles are big A, big B, and big C, and I take sides little b, little c, little a, which are opposite them. And so b over sine b equals c over sine c equals a over sine a. And so I need to find this, x. I don't want to mark that thing up yet. I want to find x, so I need this angle. Well, if this is 74, it's an exterior angle of a triangle adjacent to an interior angle. So it equals the sum of these two angles. 74 equals 42 plus, I'll just call it, I don't want to, I'll use q. 42 plus q. Q is this angle, q equals. And so I subtract 42, and it's 32. So q is 32 degrees. So now I can use the law of sine. X over sine 32 degrees. Let me fix something here. Let me see if I can fix something. Equals, and then I get 130, the side, opposite the angle. I guess that didn't work. I want this one, 130 over, and then I go sine of 42 degrees. Then I multiply both sides by sine of 32. And so that's what x is. X is equal to 130 times sine of 32 degrees divided by sine of 42 degrees. I will show that in a moment on Desmos, but before I do that, and you would do it on your calculator, make sure in your degrees mode. But before I do that, I want to show how to do it without the law of sines, because on December 1st, that's where this class is. So first, I want to find two sides of this big triangle. I'm going to put that in red. I want to find two sides of this big triangle because then I can find what x is. So I'm going to look at this little triangle. I'll draw that one in blue. I'm going to look at this little triangle, and I'm going to see if I can find this side. I'll call it y. Y equals, and this is a 90-degree angle, so the hypotenuse is 130. So sine of 74 degrees equals y divided by 130, the hypotenuse. And if I multiply both sides by 130, y equals 130 times sine of 74 degrees. And then I can also find this, I'll call z. I can either use the Pythagorean theorem. I don't want to calculate this yet and then round it, because if I do that, my final answer is going to not be exactly accurate, so I'll round it at the end. So now I want to find z, and I can use cosine of 74 degrees. Cosine 74 degrees equals adjacent, which is z divided by the hypotenuse. If I multiply both sides by 130, I have z. So now I have y, I have z, and now I can do something with this big triangle. I have 42 degrees. So I know that let's say the tangent of 42 degrees equals opposite, which is y, which is 130. I'm just going to put it in right now, 130 sine 74 degrees divided by z minus x. I'm sorry, z plus x, because this whole side of the big right triangle is z plus x. So z is 130 cosine 74. I think I need a little bit more room. 130 cosine 74 degrees plus x. How do you like that? Now I'm going to multiply both sides by 130 cosine 74 plus x, divide both sides by tangent 42. 130 times cosine 74 degrees plus x equals 130 sine 74 degrees divided by, I divide both sides by tangent 42 degrees. And now I'm going to expand my canvas, paper, whatever. So I can fit this. I'm just going to subtract 130 cosine 74 degrees minus 130 cosine 74 degrees. And that will be what x is. So now, here's one I've already prepared. Here's the one that was done with law of sines, 130 sine 32 degrees over sine 42 degrees. I am in degree mode, and it's 102.95, however you want to round it. And then here's the other one, 130 sine 74 degrees divided by tangent 42 degrees minus 130 cosine 74 degrees, 102.95. So both of them work the same. Law of sines is easier, but before you have law of sines, you have to do it this way, using just regular trigonometric identities.